Hello, Emily from RoboFlow here, and today I'll be walking you through how to build a complete computer vision pipeline to run on your RTPS stream. This will include setting up the stream to collect data into RoboFlow, then labeling the data and training a custom model, and then finally deploying that model back onto your stream to do stateful analytics, such as count the number of objects crossing a line and the amount of time they spend in a specific zone. So without further ado, let's jump right in. So before actually running the workflow, you'll need to have a camera set up with a connected RTPS stream. I'm currently running it on the Tapo outdoor camera that I got from Amazon for $35. I'll link it in the show notes, along with two other cameras, such as the Reolink, that a lot of our starter plan customers typically use when they're deploying outdoors on live streams. Next I'll show you how to get a RTPS stream URL if you're using this camera. Otherwise, you can skip to actually getting the code running. Now I'm going to generate the RTSP stream URL for my device. I've actually already gone ahead and connected my camera, but you can do so under Add Device, select your Add Camera type, and go from there. As you can see here, this camera is looking at the street outside my window, and it will be working on tracking the cars. To generate the RTSP stream URL, you'll want to go under Settings, Advanced Settings, Camera Account, Account Information, and then enter your username and password to create a unique URL. We'll start off by creating a data collection workflow that will run on the camera and on a specified interval, upload those annotated images back to RoboFlow. So without further ado, let's jump in. I'm going to create a workflow, and in this case, I'm going to try it out on a few sample images. There's a few different options here. One, you can use a common model. You can explore models on RoboFlow Universe, which is our community of public models that other users have created. Or you can try it out on Coco, which was trained on 80 most common classes, such as people, vehicles, and household objects. So I'll start off by using Coco, and I'll paste the model here. And to visualize the results, I'll go ahead and add a bounding box around the image detected, and then a label so I can see the classes found. Sweet, let's see what this does. So I'm going to drop in an image from what my camera is seeing outside in the house. And as you can see here, it returns the raw predictions, but also I can look at the visual and see all these things it found. So it found cars, it found a truck, it found people. I'm only interested in the cars and the trucks, so I can go ahead and actually filter out the classes to only include the ones I'm interested in. So if I test it again, you can see here it only found objects of interest. Looks like I misspelled truck here. Yep, that would do it. So now you can see it found all the cars I'm looking for. Let's say your classes aren't included in Coco. You can use an open vocabulary model such as Yellow World, and this can find any class you're looking for. So to get started, I'll add the car and I'll add visualizations here as well. And to test this out. And Yellow World takes significantly longer, but it's still loaded pretty fast, and you can see here it found some cars. But there's a lot of false detections. So to filter this out, I can play around with the confidence. By default, it's very low. Let's say I want to set it at 0.3, so it only finds more objects it's confident about. So as you can see here, now it reduces those low confidence predictions. Yellow World is really powerful. You can actually enter in whatever class you want. So for example, here I can put black car and let's say white car. And even though the model was not trained on those classes, it'll be able to pick them up in this image. So as you can see here, kind of finds these as black cars and these two as white cars. Not perfect, but let's say I like this model, I want to go with it. For this sake, I like the Yellow World just on car the best. So I'm going to delete everything else and stay with Yellow World. And then finally, now that I have my classes, I actually want to upload them back to RoboFlow. So add the dataset upload block. I'll choose a target project. Here, I'm going to choose my cars project. And I'm actually going to have all those predictions uploaded to RoboFlow as well. And there's a few different values you can play around with. One is the percentage of items I want to upload. Let's say I want only 50% of the data to be saved. And on this makes sense to me. Every minute I on maximum want to upload 10 images, every hour a maximum of 100, and every day a maximum 1000. So you can control how much data will be coming in within a certain amount of time. You can also play around with the image size, and you can play around with what the label is going to be called. So I will be naming this car straight view, and I'll save my workflow. And now when I run it on my test image, you can see here it actually saved this image with the annotations back in RTSP. So if I can go back on my projects page, and yes, you'll want to create a project before getting started, you can see I have my cars project, and under Annotate, I have this image pre-annotated, uploaded back to RTSP. So sweet, let's have this running or now that I have this workflow built, I'll want to actually connect it to run on my camera. So going back to my model, as you can see here, I have a lot built. I'll actually name this to data collection. And then I will select deploy workflow, and I want to run it on a video. Here you'll want to install Inference, which is our open source repository for running workflows on a video stream. And I can copy this code snippet to set it up. So now let's jump into the next part of the demo. So now that I have my workflow, I copied this deploy snippet and pasted in the code. The one modification I made is I'm actually loading my API key from secrets rather than pasting it directly. Right now, by default, it runs on your webcam. Instead, I want to use my RTPS stream that I just generated. Here you can see it follows the format of username, then password, along with the IP address. The /stream is specific to the Tapo camera that I'm using. One final thing you may note, I uncommented this result.getOutput image. You have to make sure that the output image is actually in the response of your workflow. You can double check this by clicking on the response and making sure that you have an output named output image. So by default, this was called label visualization, and I changed it for this demo. So yeah, without further ado, let's see what this workflow does. So now it's spinning it up. And as you can see here, it's running my workflow on the live stream. I limited execution to 3 frames per second max, just for this demo purposes. As you can see here, it's not picking up the bus. So on future inferences, I'm actually going to update to include that class. It's not picking up all the cars, so I'm going to drop the confidence. And yeah, let's go ahead and make those changes and see them reflected live. So going back to my model, I'm going to add bus as a class. I'm going to tweak the confidence and increase it to 0.2. And without further ado, let's see how that affects it. Sweet, so now it's picking up both the buses, it's getting a bit more of the cars. Still not perfect, and that's why I'm going to fine tune a model. As you can see here, now it's actually sending all these annotated images back to RiboFlow, collecting the data, and it's actually getting both the buses and the cars. There'll be some false predictions, so I'll definitely want to clean up this data before training my model. So I'll let this run for a few minutes, maybe a few hours, and I'll come back here for part 3. Now that I've had my data collection workflow running for about a couple hours, now I've collected 300 images that I'm going to go ahead and start annotating. So I'm going to assign them to myself, and then go through each image and make sure that the predictions all match. So as you can see here, it's missing a car. Clean up the label. And besides that, there's a sneaky one in the back. Looks good. I'll want to do that for all the images in the dataset to make sure my model is training correctly. We'll check back in a bit. So once I went through and updated the images to make sure that all the cars and the buses were labeled correctly, I can go ahead and generate a dataset version for training. So here I'll resize the images. I'll up the resolution to 1000 by 1000 since that's closer to what my camera is seeing. And I want it to fit within black edges so it doesn't actually change the dimensions. Images typically train better on square images, so that's why I'm adding it this way. And then I'll add some augmentation steps. I will add some brightness since I'll have images both in nighttime and daytime. I'll add a little bit of blur. As you can see here, you still want the image to be visible, So I'll add just a tiny bit. And then I'll play around with some hue and saturation to give it some more color exposure. So overall, the augmentation, you want it to capture what the model will actually see in the real world. So I'll play around with some lighting some more. It looks good to me. Then I'll go ahead and generate the dataset version, and I'll generate 3x augmentations just so I have more variety in the training data. So going to give it a few seconds to generate my version. And then voila, it's ready for training. I'm going to train with RoboFlow. And I'm going to use RoboFlow 3.0. And I want to have an accurate train. And I'm going to use the Cocoa as the checkpoint. And I'll go ahead and kick it off. Sweet, I'll check back once it's ready. Sweet, now that my model has finished training, let's see how it performs. First, I'll want to look at the different metrics. It looks like it's pretty good at identifying cars, but doesn't find all of them. But let's actually look at the model evaluation to see how it performs. So a lot of the times it finds the car and correctly labels it as car, but there are 60 cases when it actually misses it. Looking through these, I can actually see the difference between the ground truth and the model predictions. So as you can see, in this example, it missed that bus and that image. Continuing to flick it through, this model actually performed better because I had a motorcycle missing in my labeling. And I can continue to go through and analyze how the model's doing. I can also tag all these images for review or relabeling, and then apply them in the dataset tab to go back and look at the results. One other thing I can try is, let me move it, going to the visualize page and test my model on actual images. So here I can see it's missing the bus, but I can actually increase the overlap threshold. Let's say send it 85%. And that means if two bounding boxes have 85% overlap, they'll still show up. And that's the reason this bus was filtered out. It was too close to the other one. So flipping through a few images, it looks like the model is performing significantly better than the previous one. So actually, let's try it out on my data. Jumping back to the workflows page. And I have my data collection. Let's try running this workflow again, but without the dataset upload to see first how it was doing originally, and then how it was doing once we replaced it with the new model. So looking into the code, I will go back to my data collection workflow and test it out. Looks like I'm not saving the sample image. Let me try that again. So this is my original workflow using Yellow World. You can see it's missing these cars in the background. And sometimes with this overlap, the car flickers in and out. So let's actually replace the model. Go back to my Yellow World and instead add an object detection model. Here I will want to use my cars model that I recently trained. And then I want to connect these bounding box and label visualization to map to this object detection. So to do so, I can actually go ahead and update the configuration. So instead of the predictions, it will be using this new object detection model predictions. And same with the label visualization. Now that it's correctly routed, I can delete the original model. So now I'll be using my new one. So jumping back to the code, this is going to spin up the inference server, download the model weights, download the latest workflow, and start running it on my RTSP stream. So now you can see here, it's getting the bus, it's getting all the cars in the background. It's actually performing a lot better than my Yellow World. So cool, fine-tuning the model had some benefits. So you can see here, right now there's 100% overlap, so that car is missing. So I can continue playing around with the parameters to really get the best results. But actually, I'm going to show you how to build a stateful workflow. So starting off with this model, I want to see, have a unique ID for each car, so I know across different frames it's the same object. So for this, I'll want to write a byte track. And this will be able to keep in mind that this is the same object. Here it needs metadata. I will go and add this video metadata, and this kind of keep tracks of frames per second and other configurations we need to run this workflow on video. And then next, I'll actually add a line counter. I want to add a line and see how many objects pass through it. So I'll set the metadata again. And now I actually want to get that line segment. For this, we're still working on building it into the UI, so I will go to polyzone.roboflow.com and you're able to drag in an image and test it out. So in this case, I will probably go back to my project and download one of the images. So let me save this so far. Go back to my projects tab. Go to my car image. And let me try it out on just this sample image. And dragging it into the polyzone. I want to add a line that goes from here to here and counts the number of cars crossing it. So now that I have this point array, I can paste it back inside my workflow. And then I'll also want to visualize the number of objects crossing the line. So let me add a line counter visualization. I'll paste in the same zone. And here I want to have the count in and also the count out. And this will be keeping track of objects going both ways across the line. And finally, I want this to visualize also the bounding boxes. So instead of taking the input image, I'm actually going to take the label visualization as input. So now you can see here, this final line counter visualization will have all the boxes, all the labels, along with how many objects cross the line. So let me update this so the output image is no longer the labeled image, but I actually want this line counter visualization to be what I'm showing. Let's try this again. So I was investigating why it didn't count the car crossing the line, and I realized I had my max frame per second to set to 1. I want to increase that to 10 since it needs more information to actually know that objects are crossing the line. So now that I'm running this workflow, you can see here that it's actually able to count the number of objects crossing the line. It gets the bus going in, it gets the cars going out. So performing significantly better, and it's getting the results we want. One thing to note is that this car, I might want to play around with the overlap threshold so it shows even if there's some overlapping boxes. To do that, I can go back to my workflow, go my object detection model, and play around with these different optional parameters. I'm actually drop my confidence to 0.3 and my overlap to 0.85. And this should just have more results returned, which I am looking for. Finally, the last thing I'll want to do is count how long objects spend in a specific zone. So for this, I'll add a time and zone block. And then I can use the video metadata, and then I'll want to actually specify the polyzone. So for this, I'll go back to my polygon zone tool, and I will specify the area that I am interested in, which is this one right here. You can copy this array, paste it back in, and see, now it's counting how long objects spend in the zone. To visualize it, I will add this polyzone visualization using the same zone. And I want this to be the output image I'm looking at, so going back before this is the output image, I'll change that. I'll actually delete the old one and change this to be the output image that I'm looking at. So let's see what this returns. So now you can see the zone. You can see the cars passing through it. I'll actually want to update the labels to show how long each object's spending in the zone. So jumping back into my workflow, I'm going to update my label visualization. Here you can look at all the different parameters. I'm interested in the text to display, and I want to display the time and zone. So now that I save this workflow, restart and rerun it. And now you can see time and zone. So this is the labels being shown. And in a second, as soon as they start sneaking in, you will see this showing the times. Okay, let's debug why this isn't working. This would do it. I want the label visualization to be using the time and zone predictions. So let's save this. So now you can see as the cars drive through the zone, it says how long they are spending inside of it. This bus is still in the zone, so it's counting the seconds, and as soon as they leave, it stops. To recap what we worked on, I was able to fine-tune a model that does vehicle detection on my RTSP stream. It visualizes the objects detected and the labels, counts the number of objects crossing a line, and how long they spend in the target zone. I'll have a part 2 coming out soon on actually how to export this data to your databases or CSV, and how to send notifications based on the results. Thanks for watching.